This is a mini project I'm running in my Scout group. It's designed for people with absolutely no knowledge of electronics whatsoever. And it requires a handful of components. It cost about £6 or £7 off the top of my head. It's quite a fun little project. We're going to do it in 3 stages. The first stage will be to just get one of these LEDs here lighting when you press the button. The second stage is I will get that LED to flash. And the third stage, we'll get the electronic dice up and running. I broke it down into 3 stages because it's easy to test then. Because if you don't get the LED to light in the first stage, there's no point in proceeding to the second stage. Similarly, if you don't get the LED flashing in the second stage, there's no point doing the third stage. So the components are, we've got a breadboard, obviously, a long breadboard. I think it's 830 points or something off the top of my head. A 9-volt battery, a 4017 decade counter, a 555 timer, 6 approximate 2-volt LEDs, a push button, a 1 microfarad capacitor. We have a 1K resistor there and a 10K resistor, bunch of jumper wires, and one of these rather nifty battery connectors here. Before we start the build, it's probably a good idea just to go through the mechanics of breadboarding. This is a breadboard. It's used for building and testing electronics. It just looks like a block with a load of holes in, really. The idea is that you push the components into the holes like so, and you can connect them up. So I can connect this capacitor here like so. You can see it goes quite nicely into the holes. You've got to be quite careful sometimes with these components that you don't bend the pins, but on the whole they're fairly robust. There are some rules to breadboarding. These columns here are all connected. So if I look at this here, that is connected to this, and this, but it's not connected to anything else. So each of these columns here, you've got 5 holes that are connected. There you go, like that. Similarly at the bottom, these 5 holes are connected. And these 5 holes are connected to each other. And these 5 holes are connected to each other. So if you want to connect something up like a switch, you've got to go across the gully like this. So that these top pins here are not connected to the bottom pins here until I press the button, if you get my drift. It's the same with the power. We'll be connecting the battery to the power rails, so plus will be going to red and minus will be going to blue. The power will run along here, so that all of these top red holes here are connected up to here. If you want to jump across the power to jump across to here, you've got to bridge this gap here with a wire like this. There we go, bridge it like that. And similarly, if you want to bridge the negative, got to bridge that with a wire like so. So now the top power rails here are connected, but these are not actually connected to the bottom power rail. So if we want to connect the bottom power rail up, I've got to connect positive here to positive here. Similarly, I have to connect negative to negative. So now we've got a complete route for the current from here over the gap via these wires, across to here, over to the other side of the breadboard, and across to here. We've got to bridge these as well, haven't we? So let's add a couple more wires in. So negative to negative and positive to positive. So you can see now that the power rails are all connected. For our project, we don't actually need to connect them all with wires. but let's just give you an idea what's going on. So for now I'll just disconnect these and then we'll crack on with the build. We'll start off with the first stage, which is just getting an LED to light on a button press. So for that we'll need the battery, a button, an LED, some wires and the battery connector. We'll start off wiring the battery connector up first. That's a good place to start. We don't need the battery right now. We'll connect that right at the end, so let's move that out of the way. The way that we're going to wire this up, if you notice the battery connector has got a red and a black wire. We're simply going to wire the red wire up to the red power terminal, like so, right at the top left hand corner, and we're going to wire the black to one of the blue terminals right underneath it. Now we're going to put a button in, so we'll take the push button, quite small these. If you turn it around you'll notice that the pins are a bit more spread out if you turn it one way, that way. So that's the way we're going to put it in the board. Where the pins are bent outwards, we're going to drop it in the board like that. And it's got to go about here, I think. Let's drop it in here. So we're going 2 pins in from the left. In fact, the leftmost pin of the switch is directly above the first of the power pins. So push that down. If you notice, it's spanning the gully as well, so the top pins and the bottom pins are on opposite sides of the breadboard. It doesn't make any sense if they're both on the same side of the breadboard, because it would just short the switch out. So the idea behind this is, if I press the button, the pins here will be connected to the pins here electrically, and when I let go the pins won't be connected electrically, thus making a switch. Right, we also need to connect the top and the bottom power rails up, so let's do that now before we forget. I'm using colour-coded wire. You'll have a bunch of wires that are probably all different colours. I'm just using logical colours to make it a bit easier for you to follow. So we're going to connect the positive and the negative. So I'm going to pick a red and a black wire for me. We're going to connect this pin here right next to the battery red pin. We're going to connect that down here to the corresponding red pin on the bottom power rail. And we're going to do the same for the black. So we're going to connect this pin here on the blue holes over to the bottom down here to a blue hole. So we should now have power to the top power rail and power crossing via these wires down to the bottom power rail. We're going to put a couple more components on now. So we'll start off with the resistor. We'll pick the 1K resistor. For my scout group, I'll have already bent this. So the 1K resistor is bent like this, and the 10K resistor we'll be using later is bent differently like that. The reason for that will become apparent later. So we're going to pick the 1K resistor, and we're going to use that to bridge the power rail here. So it's going to go across this gap like so. So the idea behind that is this resistor will limit the power, because that's what resistors do, limit the current for the LED in the battery circuit. Because if you give one of these LEDs a full 9 volts, it'll quickly go pop. but by sticking a 1k resistor in, it will limit the current to a more tolerable value for the LED. And whilst we're on the subject of LEDs, let's put one of those in now. So LEDs are a little bit like little light bulbs, but they're actually diodes. Now diodes only allow the current to flow one way, and they block the current the other way. LEDs are the same, but they're light emitting diodes. LED, light emitting diode. And you'll notice, if you look very carefully, let's see if you can get that close to the camera, one of the pins is ever so slightly longer than the other. So you can see on this, the pin on the right is slightly longer than the one on the left. Now the longer pin, this longer pin, is the anode. It's the positive side of the LED. And the shorter pin is called the cathode, which is the negative side of the LED. So what we're going to do is we're going to put the shorter side on, because it's the negative side, on the power rail here. And the longer side we're going to connect up to the breadboard. To do that, we're going to get the longer pin and bend it gently. So I'm bending the longer pin so it looks a little bit like that. Put it down so you can see. Just bending the longer pin so it's got that kind of shape. And then we're going to take this LED and we're going to put it, might have to bend it a little bit more. The cathode, the negative side, the shorter pin, is going to go in the blue power rail, the negative power rail, and the, let's see if we can get this on camera. So the negative side, the shorter pin, is going in here, and the positive side is going into one of the holes here above it on the main breadboard block. So I'm going to push that down gently. So we've got one of the LEDs connected. So just to be clear, that's the negative pin and that's the positive pin. So you can get a bit of a closer shot there, so you can see what's going on. So that's the bent longer pin there. So while I'm here, you can see how the switch is connected and the power is connected. Okay, got a couple more wires to go and then we're going to test it. So we just need to wire the switch up now to the LED. So the switch isn't currently connected to anything. So what we have to do is connect the current to the switch and then the other side of the switch to the LED. I'm going to do that in 2 stages because we're going to reuse some of this wiring later. So the first stage is, let's get this a bit closer again. I'm going to connect my red terminal here. It'll go in. So I've connected red there to near one of the switch pins there. So you can see that. So we've got red to switch. We're going to do the same up here. We're going to connect the diagonally opposite pin of the switch. So you can see I'm connecting that pin there with the diagonally opposite pin there. I'm just going to place it somewhere on the board. Probably about, I don't know, here. That might do it. About here. That should do. So I've actually connected it to the pin that was just below that block of 5 pins in the power rail. And then finally I'm going to use a longer wire to connect this here to the LED there. I think that's right. So we have quite a spaghetti junction going on there, but that should work. So just to recap, what I've just done is I've wired up a switch here to the power. So it's the bottom right pin of the switch to power with that wire, that to that, and then the top left pin of the switch is connected to this row or this column of the breadboard, and then also in that column I've connected a longer wire to the anode of the LED, so that's in the same column here as that pin there. So the idea behind this is when I press the button, the current will flow from here to here, but it won't do anything until I press the switch. When I press the switch, it will close the circuit. Current will then flow to here, light the LED. Got a little bit of a resistor in there to stop the LED from blowing up by lighting it too brightly. And then the return path to the battery here, negative pin here, which goes back up to here and to the battery. So we need to test that now. Testing. Connecting a 9-volt battery is fun, because if you look at the 9-volt battery, you've got one pin that looks like a circle and another pin that is a 6-sided shape. And if you look at the battery connector, you notice you've got the same arrangement. So the idea is the circle connector on the battery goes to the opposite connector on the battery connector. So circle to, what's a 6-sided shape? Is it a hexagon? That sounds about right. Circle to hexagon and hexagon to circle. If you connect it that way, the chances are you might blow something up later, so it's important you remember to connect the battery up the correct way. So let's do that now. Put that there. Let's press the button and see what happens. There we go. I press the button and the LED lights. Fantastic. So we're going to start phase 2 now, which is to make this LED flash. Now to do this, we're going to get rid of one of the wires. So let's get rid of this long wire here that just connects the switch to the LED. We can keep the rest of the wires in place. Let's put that there for the moment. We're going to get one of the chips out. So it's the smaller chip. If you look at the chip container, you've got one which has got a small chip in with 8 legs. That's the 555 timer. And you've got a longer chip which has got 3, 4, 5, 6, 7, 8, 16 legs. So it's twice the size of the 555 timer. This is the decade counter, which we'll be using later. So let's just put that to one side for the moment and get the 555 timer out. You can get that out, it'll either fall out or you can push it out gently with a pencil. That's just fallen out, which is quite good. So let's have a look at the 555 timer in detail. So it's got 8 pins, and if you look very carefully, it's got a small circle inscribed on the top. That marks the orientation of the chip. Let me just get a Sharpie and see if I can highlight that for you. Hang on a second. Right, so let's try and put a dot on this so you can see where it is. Just bear with me 1 second. Okay. So now I've got a dot where the dot on your 5.5 timer should be. It should be about there. It's a bit clearer now, isn't it? So that indicates where pin 1 is. So these have got a polarity. All of these pins have got a different function. So that's pin 1. So we're going to count at the bottom, left to right, 1, 2, 3, 4. And then pin 5 starts at the top right. So that's pin 5, 6, 7 and 8. So generally all chips are like this. You'll have some notch or some marking to indicate where the first pin is, and you count from left to right at the bottom, 1 to however many pins there are, and then from the top you count from right to left. So in this case it'll be 5, 6, 7 and 8. We're going to put the 555 timer here, so that pins 1 and 8 are in the same column as this power here. You might have to bend the pins slightly. So if you look on mine, the pins are at 90 degrees. Yours might be sticking out a bit. So the way that you do that is you very, very gently take the chip and just squeeze the pins in until they're at 90 degrees, and that will make it easier to put in the breadboard. So remember where the notch is. Notch goes to the left, and like the switch, it's going to span that gap across the breadboard. So let's push that in. I'm going to disconnect the battery actually while I'm doing this. Don't forget to disconnect the battery before you do this. Right, let's have a look. So you can see the 555 timer, and this pin here is in the same column. Pin 8 is in the same column as the wire we put in previously. The reason for that is pin 8 is the power connector, power pin for the 555 timer. And pin 1 is negative, or ground as we call it in electronics. There are a couple of things that we need to wire up with a 555 timer now. So let me get a wire. First thing we need to do is bridge pins 2 and 6. So that's pin 2. Let's get a bit closer so you can see what's going on. So I'm going to connect pin 2 here, like that, to pin 6, which is, if you remember, it's counting right to left at the top. So that's pin 5, pin 6, pin 5, pin 6. So we're going to connect those 2 pins together, like so. I think that's right. And we're going to stick the second resistor in. Now resistors don't have a polarity, you'll be pleased to hear. So it doesn't really matter which way they go. And the resistor is going to connect pins 2 and pins 3 of the 555 timer. So let's do that now. Let's connect pins 2 and 3, like so. So blue wire, in my instance, between pins 2 and 6, and the resistor is connected between pins 2 and 3, like so. Right, and we need to connect the negative pin up. So let me get another cable. So pin 1 of the 555 timer here. I can connect it at the bottom here because all of these are connected. So the row that pin 1 is in, if you can see, that's in the same row as pin 1. I'm going to connect to the blue strip on the power. So that's connected to negative, like so. Starting to look a bit busy on here. We've just got two more things to connect up. So the next thing is we need to get the capacitor, the 1 microfarad capacitor. So this is the capacitor. It has a polarity like the LEDs, and one pin is slightly longer than the other pin. Now in this instance, the shorter pin connects to negative, and capacitor manufacturers, if you can just about see there, always mark the negative side of a capacitor with a minus sign, some kind of stripe. So we've got a grey stripe and a minus sign. So you've got 2 tells here for a electrolytic capacitor. Now what we're going to do here is we're going to connect pin 5 to the negative side of the battery. And the way we're going to do that is we're going to bend the pins slightly. These are quite thin, so just be careful you don't bend them too much, just so that we can bridge the gap. And this is connected in the same row as the blue cable, so it's pin 5 again. I connect it at the top of the row here of pin 5, and that's going to get connected. So the negative side, if you remember, with the shorter pin and the minus symbol, is connected to the negative of the power rail up here. So let's just have a look at that in more detail. Let's just double check we've got this right. So that's pin 4 now, no, pin 5 now. So that's pin 6. That's correct. So pin 6 with the blue wire in it is in the same row as the capacitor, and the capacitor here is connected from the main block of the breadboard to the negative power rail here, the blue power rail. And we've also made sure that the negative side of the capacitor is connected to the negative side of the power rail. Otherwise there's a danger you might blow the capacitor up, or at the very least this circuit won't work properly. So that's the capacitor in. The final step is to connect the LED up to all of this. So we're going to take the longer wire again, and we're going to connect pin 3, which is, let's have a look, pin 3 is here. So it's the second pin of the resistor, isn't it? Pin 3. So we'll connect pin 3 of the 555 timer, and we'll connect it over to where it was connected before, which is to the positive pin of the LED, like so. So the next step is, will this actually work? So again, get the battery connector, get the battery, make sure that we've got opposite shapes, so round to hexagon and vice versa. Is it hexagon? Anyway, connect that up. Let's see if this works. Okay, it might be flashing a bit too fast for you guys, but that's clearly flashing for me. You might have to view it on a camera phone. If the LED lights up, then you're probably doing it right. The final stage is to put the rest of the LEDs in and get this dice working. So the first thing we're going to do, which is what we forgot last time, disconnect the battery. Like so. Put that somewhere safe. We're going to disconnect the long wire we put in from the 555 timer to the LED again. Sort that out in a minute. We're going to put in the 4017 decade counter. So let's put this. Now this has got a notch and a circle. So in this instance, if you can see here, you see the notch and the circle quite clearly. If it's got a notch there, we use the notch to mark pins 1. So we've got pins 1 through to 8 at the bottom, and then 9 through to 16 at the top. Okay, so let's get this chip in. So remember to bend the pins slightly before you put it in, gently. And we're going to mount this probably here. So I'll mount it so that it's roughly in line with this column here, the start of this block of 5 power pins. So let's push that in gently. Make sure you don't bend the pins. There we go. So the first thing we need to do is wire the 555 timer up. No, let's wire power up first. So the chip needs power. So in this case it's pin 16, top left pin is the power pin. So connect that to positive. And pin 8 is the negative, so that's the bottom right. It's quite common for chips, for top left to be power and bottom right to be negative or ground. So let's connect this one to ground. Let's see what you're doing here. There we go. So it's connected to ground. So the top pin there is connected to red, and the bottom pin is connected to blue. We're also going to connect one more thing to ground, which is pin 9, 10, 11, 12, 13. I think it's pin 13 here. We're going to connect to ground like so. So now we need to connect the 555 timer up to it. I'll explain what's happening. So what was happening with the 555 timer here, it was generating a pulse which was making the LED flash very quickly. So what we're going to do with the decade timer is capture that pulse and then use it to count from 0 to 9. It's a decade counter, and when it counts, one of these pins here will have a voltage applied to it. So I can't remember what the pins are, but the pin for 0 will have a voltage on it, and all the other ones won't. And then the next time it gets a pulse, the pin for 1 will have a voltage on it, and none of the others will. And then it'll count through to 9, putting a voltage on all of the pins, the relevant pins. And then when it gets back to 0, it will loop, and it will do the light up the voltage for pin 0 again. So we're going to take advantage of that, but we're also going to make it just count up to 6, because there's a reset we can apply. So once it counts up to 6, we can make the chip reset and go back to pin 0. So first we're going to get the pulse in. So the pulse will connect pin 3 of the 555 timer again. So it's the one here in the same row as one of the pins of the resistor. And we're going to connect that to pin, let me see, 16, 15, 14, pin 14. So it's 16, 15, 14. Look. In fact, we could probably move this wire down here to make it a bit clearer. There we go. So we've got clock to ground. We've got this yellow wire I've put in, which is on pin 14 to the 555 timer. So that's receiving the pulse on the 555 timer now. And the pin next to that is reset. And that's going to get connected to pin 15 here. And that's going to loop over to pin 5. So let's count those out now. 1, 2, 3, 4, 5. Like so. That's looking like a bit of a rat's nest, isn't it? Hopefully this will work. The next thing we need to do is wire up some more LEDs. So remember to bend the long pin out. We're going to space them out. Let me see. We could do it every space them out a bit like this. All wired up the same way. So the shorter pin all in the negative, longer pin, the bent pin, all in the breadboard body, waiting to be connected to the decade counter. So now we're going to wire the LEDs up. So this is fairly straightforward, albeit a bit fiddly. So we're going to wire up the first 4 pins of the decade counter to the first 4 LEDs. So let's start that off. Let's do the first row. Connect it to any in that row. I'll connect it to the ones nearest the pin so it's clearer. So connect pin 1 to LED 1. You see how that works? Pin 1 is connected to LED 1. And pin 2 to the second LED. Let's connect that up. See pin 2 there. It's connected to the second LED. Pin 3 is connected. You can see where this is going. Pin 3 is connected to the third LED. And pin 4 is connected to the fourth LED. And now it starts getting a bit funky because pin 5 is connected to something. So what do we connect up next? It's pin 7 is connected up to the 5th LED. So pin 7 is there. And we connect that up to the 7th LED, the 5th LED, like so. Let's make sure it's in nice and tight. And then we've got one more LED to connect, which is pin 9. So pin 9, so that's pin 8. Pin 9 connects to the final LED. I think that's there like so. So we should have quite a mess of wires there. But you can see the orange wires. We've got 1, 2, 3 and 4 and pin 7 connected up to the LEDs, and also pin 9 there. So the next step is to see whether this works. Let's connect the battery up. Fingers crossed. Okay, we've got 2 lights as usual. You can see the LEDs are flashing. That's good. So you press the button, the LEDs flash, and when you let go, you get a random number. So that's like a dice throw of 3, that's like a dice throw of 5, 2, 1, 2, 3, 1, 6. There we go. A completed dice project. If you like what I'm doing, then please subscribe to my channel.